Problem number 3, we have the homogeneous bar shown in the figure is supported by a smooth pin at C and the cable that runs from A to B around the smooth peg at B. Find the stress in the cable if its diameter is 0.6 inch and the bar weighs 6,000 pounds. The first thing that we are going to do here is to draw the free body diagram. So at point A, so we have here the tensile force in the cable, that's P, and the same force is acting at point B. So this is also force P. Now here at point A, so this force P has the slope of 3 rise and 5 run. So computing for the diagonal, so we have the square root of 3 square plus 5 square, and that is equal to square root of 34. So we have here the diagonal of square root of 34. Okay, so since we have a hinge support at point C, meaning at point C we have two reactions. This is the CX and the CY. So since we are asked to find the stress of the cable, given is the diameter, which is 0.6 inch. So yung given natin, we have the diameter is equal to 0.6 inch. And we have the weight of the bar, which is 6,000 pounds. So first thing that we are going to do is to find the value of P. So in order for us to solve for the value of P, we have to summate moment at point C. So we have the summation of moment at C is equal to 0, taking the clockwise direction as positive. This P here sa point A will have two components. We have the Py and the Px. So taking the moment, Py will rotate clockwise, so that would give us positive moment. So it's Py multiplied with the perpendicular distance, which is 10 meters. And si Px ay tatama dito sa point C, therefore Px will not create a moment. And the force P dito sa point B natin will create a clockwise rotation, so that's P multiplied by the perpendicular distance, which is 5 meters. And the weight of the bar. Okay, so for the weight of the bar, it is acting at the centroid, of course, that is 5 meters from point A and 5 meters from point C. And that would also be acting at point B, and this is 6,000 pounds. So the weight of the bar will create a counterclockwise rotation. So that is negative 6,000 pounds multiplied by the distance of 5 meters, and that is equal to 0. So, ba't hindi natin convert yung 5 meters into inch or into foot para consistent yung unit natin? So, actually, dito ay makakancel lang naman yung distance, and yung lalabas is 4, so hindi naman siya maka-apekto. So, for the component Py, as you can see, we have here the component, so that is P multiplied with the vertical component, so that's 3 over the diagonal square root of 34. So we have 2957.13 and the unit is in pound. Since we already have the value of P, then pwede na natin makompute yung stress since stress is equal to force over the area. So stress is equal to force. The force is 2957.13 and the area, since given yung diameter, so that's pi diameter 0.6 inch square over 4. And solving for the stress, we have 2957.13 divided by pi times 0.6 square over 4. And the stress is 10,458.71. And the unit is pound per inch square, and that is PSI. And this is our answer.